Okay. So after having implemented everything, what are some of your general reflections and things you'd like to improve on moving forward?
Well, right off the bat, my immediate reflection is that I definitely need to be using this in as many lessons as possible, as many times throughout the week as possible, because this is the best student work that I've received yet, in terms of being able to actually see students' thought processes throughout the entire throughout all of their answers. And while it's the highest level of mastery I've ever seen with this standard, like having taught it twice before, it's the highest I've ever seen, students still had trouble being able to actually justify some of their answers on paper. So one thing that I would improve upon this by definitely doing it a whole lot more often, because the more practice that students get with this type of work, the more that they'll be able to actually be able to justify their answers.
How has this set you up to be a stronger instructional leader in the future?
This is one thing that I definitely feel a lot more confident in taking something like this to other teachers throughout my campus, and not only that, but also taking it throughout the rest of my career in education, because it's something that I 100% believe in now. It's something that can get students to a higher level of mastery a lot more quickly than I thought before, and it helps them understand the process, helps them understand, conceptualize it a whole lot more. And so this is something that I would definitely take through. I feel very confident in taking to other teachers.
And what did you learn from this particular lesson that you taught? So I know that the lesson was on, it was basically a bunch of different things, particularly that having to do with parabolas. So from this individual objective in this individual lesson, what did you learn?
Right, so the objective was on analyzing graphs of quadratic equations, and so it's something from this lesson I noticed that it didn't take nearly as much time as I had thought before, but also the more that students actually, the more time that they took in answering every single question, the more they were able to justify their answers, the more often they arrived at the correct answer more often than not. So that's one thing that I did notice. I also noticed though that students still were not able to necessarily to describe the difference between a linear and quadratic equation, because after having answered the question about how far the ball traveled with each second that passed, students still said that the rate, the ball fell at a constant rate, which isn't true with quadratic equations. So that's something that definitely needs to be addressed, but that's something that I think I could have worded the question a little bit better, and I could have scaffolded that question a little bit more to make sure that they arrived at that conclusion on their own, and they were able to actually identify what the difference between linear and quadratic equation.
Do you think that that's something that you would have been able to identify if you had just asked them to answer questions in terms of analyzing the graph?
In terms of just answering,
so if you'd just been okay, here's a graph, right? Here's this picture of a quadratic equation, pick A, B, or C, and then write a sentence about why you chose that. Do you think that that would have been because there's an obvious, you made a good point, there's an obvious difference between a quadratic graph and a linear graph, and I guess my question to you is if you had just done student work, if you had not changed the way that you ask kids to produce work and articulate their thought processes, do you feel like that would have been something that you could have easily identified the way that you used to kind of do work with kids?
No, I don't think so. Because the way that I used to do work with kids, it's an alternative school, so we're moving at a very quick pace, and I never had them actually try and explain their answers as much before. So I don't think that they have ever I don't think that we've actually had that kind of conceptual understanding with linear versus quadratic. It's always been we focus on linear equations and then we focus on quadratic equations, and we've not compared the two. So by providing them questions hey, like we've learned about linear equations, we've learned about quadratic equations. Here's this quadratic graph. We've analyzed it, and now like building upon that and having them explain the difference between a linear and a quadratic equation, I think would help them conceptualize quadratic equations a lot more.